Welcome back to Surface Area of Prisms, the sequel. When we last left our intrepid math adventurers, we were talking about the surface area of all other prisms, and that included pretty much anything that was not a rectangular prism. Would this work for rectangular prisms? Sure it would. Absolutely it would. But we do have specific formula for that. This is the generalized formula for anything else. All right, let's move on to a new and interesting shape called the pyramid. Mystical, magical, not really, just a pyramid. Okay, so again, we're looking at two different portions. Our lateral area, which is just the portion that is the non-base. Difference, of course, between a pyramid and a prism is that a pyramid has a singular base. Okay, so this would make up all of the lateral area, and then instead of 2 times the area of the base, we only have 1 time the area of base, just one base, because there is only one base in a pyramid. Okay, you'll also notice that we have slant height as a measurement now. When we're talking about volume, I talked to you about the difference between elevator height, going from the bottom straight up, and slant height, which would be like the escalator length, right? Slant height, which is actually kind of a cursive L, is actually escalator, or along the side, okay? Which makes sense because it's the height of the slant, right? So you're going to be multiplying the slant height times the perimeter of the base, which is essentially the base of each of the triangles, times the height of the triangles, to give you all of the lateral area plus the area of the base. All right, let's take a look at this bad boy. Only need a couple of things for this formula, making life a lot easier. Slant height, kindly provided to you as 11.7 meters. Sweet. Perimeter of the base. Looks like that is a square, 8 and 8. So these also have to be 8. So we have 8 times 8 times 8 times 8, or 4 times 8, right? 32. The only other thing that we need here is the area of the base, which is super easy because it's a rectangle, or in this case a square. So length times width, or in this case length squared, 8 squared is 64. And you'll notice we're basically just multiplying this by height. All right, so once we have the formulas we need, we substitute in our slant height, our perimeter of 32, and our area of the base, which is 64, and you should have gotten 251.2 meters squared. Now, there are a lot of obnoxious things about pyramids and calculating the surface area of pyramids, okay? One of the obnoxious things about the surface area of pyramids, in general, the diagrams of pyramids just kind of suck. Why do the diagrams of pyramids suck? I don't know. They just appear to be the awkwardest of shapes. So a lot of times it can be really hard to tell what it's pointing at, right? The other things that are difficult about it is because there's a lot of right angles involved, they tend to make you solve for a missing piece of information using Pythagorean Theorem. Other annoying piece of information or useful piece of information is oftentimes you can apply special right triangle rules by dividing it up, okay? So do with that what you will. Let's take a look at this one, which has a slightly different base. Another pyramid, just a pyramid, instead of set up on a square, it's set up on a triangle, triangular based pyramid, okay? Still looking for the same stuff. We're looking for a slant height given to us, don't have to solve for it, it makes our life easy. All right, and then perimeter of our base. Again, this looks like an equilateral triangle, so it's just going to be 10 plus 10 plus 10. Live it on easy street here. Sweet. And then finally the area of the base. Area of a triangle formula is 1/2 the base of the triangle, which we know to be 10, times the height of the triangle, which was provided to us as 8.7. You'll notice that the height of the triangle and the height the slant height are not the same thing. Be careful. So once we've identified our necessary variables and done those calculations, we plug them into our formula of surface area being equal to 1/2 slant height plus perimeter plus the area of the base. We end up with 144 inches square. Spiffy. Moving right along. Why don't you give these two a try on your own? Pause the video and return when you have accomplished your task. Cool. I'm going to assume that you are done. So on this first one, hopefully you picked up on the fact that it is a square-based pyramid. They have provided you a height, or a slant height. So you're doing 1/2 your slant height of 7.4 times the perimeter of the base, 5 plus 5 plus 5 plus 5, plus the area of the base, which is just 5 times 5. And you should have gotten 99 inches. This one, both tricky and easier in both ways, okay? First thing that you may have noticed right off the bat, they gave you the area of the base. That big B provided for you. So you did not have to find the area of the bottom base figure, which is nice because it's a 6-sided figure, and that's a little more complicated. Could you do it? Yes. Do you want to do it? Not if you don't have to. All right, so same formula, 11.3 slant height plus the perimeter of the base, since it's a 6-sided figure and each side is 6 yards. 6 times 6 gives us 36. Hopefully you remember that this is a regular shape. Remember, we call it regular if all the sides are equal. And then the area of the base, which we just plunk in here from being given to us, giving you 296.93 yards square. This one's not on your formula sheet, so take a minute to look up and check this one out. Okay, we've got the roof on a shed of a square base pyramid. A roof, you say. So whenever I have a word problem of any nature, I am typically going to try to draw it because I find that to make my life easier. So I've got a roof, and it's on a shed of a square base pyramid. So square base pyramid roof, okay? Here's our hastily drawn shed of dubious quality. All right, so we're talking about the roof portion. If the base has a side length of 10 feet, okay, so we know that's 10, and the slant height is 9.4, all right, 9.4 helps to label. Find the area of the roof. Cool beans, we can do that, all right? So we know that the surface area is going to be equal to this. However, because it is a roof, there is a portion of this area I do not need. We are talking about only the roof. So the base of this shape will be excluded from the calculation because it is the part that is going to be in contact with another shape. It's not exposed to the outside of the shape. So in this case, I'm just going to go ahead and use the lateral area formula because I don't need this plus b portion, okay? So I'm going to set it up without the plus b. 1/2 the slant height times the perimeter. It's got 4 sides of the base, and each of them is 10, so 40. Should give me just 188 feet squared. So remember, in a lot of word problems, you need to find just the lateral area and be careful about excluding bases. Cylinder and cones. Cylinder and cones also have their own special formulas, even though they are kind of prisms and pyramids in their own right. You'll notice that the circumference formula is included here as part of the lateral area formula. That's because the circumference of the circle creates the length of the lateral area, and that is times the height of the figure. So circumference times height gives you the lateral area, or this square part, and then 2 times pi r squared gives you 2 bases. This is super easy. I'm not going to spend a lot of time on this, okay? You should be able to identify and substitute in for the radius and the height, okay? Our radius here is half of our diameter. You just have to make sure that you're not using the full diameter, 7.5. And then our height, don't get fooled, is the distance between the 2 bases, so it is 9. Substitute that in, gives you 463.38. Okay? Occasionally on a cylinder problem, here's 2 for you to try on your own. They will ask you to use Pythagorean Theorem to solve for a missing portion. Here, for example, you're going to use Pythagorean Theorem to find the diameter so that you can get the radius. Go ahead and pause and return when you've completed these 2 problems. Okay, so hopefully you set up your Pythagorean Theorem correctly. You're solving for x here, and your other leg is 32. Your hypotenuse is 40, giving you x is equal to 24, which means that your radius is 12, with a height of 32, giving you 3,317.52 millimeters square. Soup can is surface area of this amount, and the diameter of the can is 3 inches. We're trying to find the height. So in this case, we're actually setting it up so that the surface area is given as an equation, and we're solving for h as the variable. So we're still using 2 times pi r squared, where the radius is half of our diameter of 3, plus 2 times pi r h. All right, and we're substituting in 1.5 again here and leaving h as our unknown variable. Then you can leave this in terms of pi or create an actual value, or honestly just substitute into Desmos, and you should get that your height is equal to 4. That takes us, of course, to cones, okay? And the cone's lateral area is kind of a wedge shape, right? A 3-dimensional sector, if you will. And the base, of course, there's only one of them, so we're not multiplying that times 2. Again, very straightforward calculation. We only need to find 2 things, and in this case, it's the slant height and the radius. The only tricky thing they occasionally do with you is throw in a Pythagorean Theorem calculation, right? They might try to do something like this for you, and then you have to use the information given to solve for something missing. Radius is half of your diameter, or 13.5, and the slant height has been given as 32.9. Then plug and chug, and you get yourself an answer of 1,967.89. Very straightforward. Okay. Take a second, do this one on your own. You'll notice they did make you solve using Pythagorean Theorem. Heavy sigh from the room. I hear you groaning, even though I'm not there. All right, let's check it out. So surface area, you ended up with 10.5 as your radius, or 21 as the diameter. Hopefully you set that up as x squared plus 25.2 squared is equal to 27.3 squared, and then just solve that out. And then you're using slant height. Please remember to use slant height of 27 here instead of not the actual elevator height. All right, last thing we're very briefly going to go over is how to find the surface area of a figure that is a compound figure. And anytime you're working with irregular figures, your strategy should be to break it into its composite shapes, of course, of which we have here a cone sitting on top of a cylinder. So first thing I'm going to want to do is find the surface area of this cone. Easy per cheesy. We know that the diameter of the base at the bottom is 34, and since the cone is sitting on top of it, its great circle would be congruent to the bottom one, the bottom cylinder great circle. So its diameter is 34, a radius of 17, and the slant height was given to us as 20. Okay? We're also going to want to find the area of the cylinder. We can break that off into its own shape, multiply again, just a slightly different formula, using the same radius and a height of 12. Okay? Now the problem that you might see with this, if you're in the problem solving seeing issue, is that in the cylinder we have two bases, and this top base on the cylinder and the base on our pyramid are where these guys intersect, right? That's where they touch. But they're also both inside that space, and so we don't need them, okay? We need one base on the bottom because that is part of the outside shape. So we need one base, but two bases can go away. There's two ways you can do this. First thing you can do is just calculate the area of the great circle, right? And subtract two of them from your total. So first I take my answers from 1 and 2, add them together, and I subtract out two bases, 2 times pi r squared. So I took out two bases, and that's my answer. If you're feeling feisty and you want to take out the cone base from the formula and just use lateral area, you can just use lateral area. You could also alter this one so that instead of a 2 here, it has just a 1. If you make both of these changes, so you take out this base and you take out one of the bases in the calculation here, halving this essentially, then you wouldn't have to do this section here. So you can either make the change at the beginning in the formula or at the end. My recommendation would be the end so you don't mess something up as you go. Okay? Good luck. Be well. Your take-home quiz is due next class. Next class we're going to review. Class after that we're going to test. Bye guys.